All right, so this is a video for 8.4.3, which is calculating confidence intervals for proportions using RGuroo. All right, so again, I have the problem in here and I have RGuroo next to it. So to find confidence intervals for proportions, we go to analytics, we go to analysis and open the drop-down menu. We go to proportion inference and we choose the one population. So we have this window and we are going to work with this. So when we're working with proportions, we always need to know what's the sample size and what are the number of success, because the quotient between those two, like the division between the two, that proportion is your probability of success. So we have in a survey of 603 adults, 98 said that they regularly lie to people conducting surveys. We are being asked to create a 99% confidence interval for the population of adults who regularly lie to people conducting surveys. Again, we are not using Excel. We're going to use RGuroo to create a confidence interval rounding to 4 decimal places. So then what do? We go here. We need to recognize our sample size. So we surveyed 603 adults. So that's our sample size. We get the probability of success being the number of people that says yes to lying to people conducting surveys. And that's a 98. All right, so then from here, we have a proportion of success of 0.16 to 52. That's our p-hat, our point estimate on the proportion. The only thing that we need to do here is to change the confidence level to 99 to make sure that that matches your problem. And the method that we use to calculate this confidence interval is a large sample Z. And so now if I click in here, this is not going to like it because I need to factor all of my labels. So then I'm going to go back and I will do X, Y, and Z just to put something in there so that it lets you go through. Because at the end, what we need is the lower for the confidence interval and the upper for the confidence interval. We need to round to 3 decimal places. So here is, 4. So 4 decimal places is that 0.1238. And you can actually copy and paste from one place to the other. And the upper, it's 0.2012. And again, it's a 2, so we don't need to round. So that should be the confidence interval for this problem. All right. Again, the information here, this is for you to do it in Excel, which is way more complicated. So you can totally ignore this and just do what I did in here to find the confidence interval. Next problem. So I'm going to do the same. I'm going to open a new one. All right, so here we go. The city is holding a referendum on increasing property taxes to pay for a new high school. In a survey of 458 likely voters, 254 said that they will vote yes on the referendum, and we need to construct a 95% confidence interval for the proportion of likely voters who will vote yes on the referendum. So then again, we survey 458 people. So that is our sample size. From those, 254 say yes. So 254 is the amount, it's the number of successes that we had. So the 254 divided 458 is going to be 0.55458. We are going to label this. You can use any letter, it doesn't really matter. We just need to add something in there. We are finding a 95% confidence interval, so we don't need to change that. And again, our method is a large sample Z. We click in here and we have a lower bound of, 4 decimal places, right? 4 decimal places. So 0.1591, because we round. It didn't take it home. 5091. And then the other one is going to be 0.6001. 0.6001, and we don't round because it's a 0 afterwards. So that should be it. All right, so I'm gonna do 2 more. Let's do 1 more. So, I mean, 2 more. So let's just open up again, analytics, analysis, proportion, inference, 1 population. So I'll have this back up. And it says, in a survey of 329 people who attended a local professional soccer team's most recent home game, 141 said that they were fans of the visiting team. We are going to create a 95% confidence interval for the population proportion of attendees who were fans of the visiting team using RGuroo. So again, how many people do we survey? 329. So that's the sample size. From those 329, 141 responded yes to being fan of the visiting team. So then 141, it's the number of successes of whatever it was that I was interested in observing. In this case was saying yes to being fans of the visiting team. We have a 95% confidence interval with a large sample Z as my method. And then again, I am going to label this just 3 letters. And then once we do that, we click on the I and we have our confidence interval. So then we have 0.3750, but then we have a 9 afterwards. So we round up. And then for the upper one, we have 1, 2, 3, 4. So we don't need that last digit. And that should be our confidence interval. Doing one more time. I'm going to open a new one here. Again, analytics, analysis, proportion, inference, 1 population. The owner of a restaurant is reviewing customer complaints. In a random sample of 227 complaints, 57 complaints were about the slow speed of the service. Again, we need to create a 95% confidence interval for the population, for the proportion of complaints that were about the slow speed of the service. All right, so random sample of 227. That's my sample size. 57 of those were complaints about low speed. So again, that is my success because that's what I was looking for. The proportion is 0.25110. So do not think about number of success as something positive. Number of success means that you observed what you wanted to observe. Being positive or negative, it doesn't really matter. It's just a matter of, I wanted to observe this. Every time you observe that, you count that as a success. In this case, he wanted to observe complaints about the slow speed of service. So every time he found one of those, he count that as a success. So out of 227 complaints, 17 of those were about the slow speed of the service. We label this to be able to move forward. We want a 95% confidence interval, and we use a large sample C as our method. We click the I, and the lower bound for the confidence interval is 0.1947, rounding up because of the 8 that we have afterwards. And then the upper will be 0.3075, we have a 1 afterwards, so we don't need to round up. And that should be it. And so again, this is your video for 8.4.3, finding confidence intervals for population proportions using RGuroo.